Teleportation, the ability to transfer matter or energy from one point to another instantaneously, has long captivated our imaginations in science fiction novels and movies. But how much of this concept is rooted in reality, and could it ever be possible in the future? In this video, we'll explore the scientific principles behind teleportation, current advancements in the field, and the potential impact it could have on our lives in the future. Don't forget to subscribe to our channel for more thought-provoking content. Quantum teleportation, the science behind the fiction. While teleportation in the way we've come to know it from popular culture might seem far-fetched, there is a scientific concept known as quantum teleportation that has made some promising strides. Quantum teleportation involves the transfer of quantum information between 2 points, leveraging the principles of quantum mechanics. Entanglement and superposition. The key to understanding quantum teleportation lies in the concept of quantum entanglement and superposition. Quantum entanglement is a phenomenon where two or more particles become connected in such a way that the state of one particle cannot be described independently of the others, even when separated by vast distances. Superposition, on the other hand, is the idea that particles can exist in multiple states simultaneously until they are measured. Quantum teleportation experiments. In recent years, scientists have successfully demonstrated quantum teleportation between particles such as photons and atoms. These experiments have involved the transfer of quantum information over short distances in controlled laboratory settings. While this is a far cry from the teleportation of larger objects or living beings, these experiments have laid the groundwork for understanding how information can be transferred instantaneously using the principles of quantum mechanics. Teleportation and its potential applications. Though we are still a long way from teleporting humans or objects, the concept of teleportation has several potential applications that could significantly impact various industries. Communications. One of the most promising applications for quantum teleportation is in the field of communications. By leveraging the principles of quantum entanglement, it may be possible to create secure communication channels that are resistant to eavesdropping and hacking. This could revolutionize industries such as finance, defense, and cybersecurity, where secure communication is paramount. Computing. Quantum teleportation could also play a significant role in the development of quantum computers, which are expected to perform complex calculations and simulations far more efficiently than classical computers. By using quantum teleportation to transfer information between quantum bits, qubits, these computers could potentially solve problems that are currently considered unsolvable. Transportation. While teleporting humans and objects is still a distant dream, advancements in teleportation technology could potentially impact the transportation industry. For example, if it becomes possible to teleport small objects or even individual atoms, it could lead to new methods of manufacturing and transportation of goods, reducing the need for traditional shipping methods and decreasing carbon emissions. The challenges and limitations of teleportation. Despite the exciting possibilities, there are several challenges and limitations associated with teleportation that need to be addressed before it can become a reality. Preserving information and structure. One major challenge in teleportation is preserving the information and structure of the object being teleported. In the case of living organisms, this would mean maintaining the complex arrangement of atoms and molecules that make up their biological systems. As it currently stands, we do not have the technology to manipulate matter at this level of precision, making teleportation of living beings a distant prospect. Energy requirements. Another significant limitation is the energy required to perform teleportation. Current experiments involving quantum teleportation require vast amounts of energy to manipulate and maintain the entangled particles. This would need to be scaled down significantly for teleportation to become a viable option for everyday use. Decoherence. Decoherence, the process by which quantum systems lose their unique properties due to interactions with their environment, is another major obstacle for teleportation. To maintain the entangled state of particles during teleportation, it is crucial to isolate them from external influences. However, achieving this level of isolation is extremely challenging, particularly when dealing with larger systems or longer distances. Ethical and social implications. Finally, there are several ethical and social implications that need to be considered when discussing teleportation. For example, if it ever becomes possible to teleport living beings, questions surrounding personal identity and consciousness will need to be addressed. Additionally, the potential impacts on privacy, security, and the economy should be carefully considered as the technology develops. Real-world applications of quantum teleportation. Although teleportation of humans and objects may still be a distant dream, quantum teleportation has the potential to revolutionize several real-world applications. Let's explore some of these potential use cases. Secure communications. One of the most promising applications of quantum teleportation is in the realm of secure communications. By utilizing entangled particles, it is possible to create an ultra-secure communication channel that is immune to eavesdropping. This is because any attempt to intercept the transmission would cause the quantum state to collapse, alerting the intended recipients to the intrusion. This technology, known as quantum key distribution, QKD, has already been demonstrated in several experiments and is being actively developed for commercial use. Quantum computing. Quantum teleportation could also play a vital role in the development of quantum computing. Quantum computers rely on qubits, which are quantum particles that can represent both a 0 and a 1 simultaneously, thanks to the principle of superposition. By leveraging quantum teleportation, it may be possible to transmit and process information between qubits located in different parts of a quantum computer or even between separate quantum computers. This could enable the creation of powerful, distributed quantum computing networks with unparalleled processing capabilities. Transportation. While teleportation of macroscopic objects remains a distant possibility, quantum teleportation could still have implications for the transportation industry. The technology might eventually be used to transmit information about the physical properties of an object, such as its structure and composition, to a remote location where it could be reconstructed using advanced 3D printing or molecular assembly techniques. Although this would not be teleportation in the traditional sense, it could still revolutionize industries such as manufacturing, logistics, and even space exploration. Teleportation in popular culture. Teleportation has long been a staple of science fiction, capturing the imaginations of audiences around the world. From iconic examples like Star Trek's transporters to more recent depictions in movies like The Prestige and Jumper, teleportation has been a popular plot device and a fascinating concept to explore. While real-world teleportation may not yet resemble its fictional counterparts, these stories continue to inspire researchers and the public alike to dream of a future where teleportation is a reality. The ethical and societal implications of teleportation. As with any groundbreaking technology, the development of teleportation will undoubtedly raise various ethical and societal questions. In this section, we will explore some of the potential challenges and considerations that may arise as teleportation becomes a reality. Identity and consciousness. One of the most profound questions surrounding teleportation concerns the nature of identity and consciousness. If a person is teleported, is the resulting individual the same person, or has the original been destroyed and replaced by a copy? This philosophical conundrum raises questions about the nature of self and the continuity of consciousness, which could have significant implications for how we perceive and value life. Privacy and surveillance. Teleportation could potentially revolutionize transportation and travel, allowing individuals to move vast distances in an instant. However, this newfound freedom could also come with significant privacy concerns. Governments and other entities may be tempted to use teleportation technology to track and monitor the movements of individuals, potentially leading to a loss of privacy and civil liberties. Security and terrorism. The ability to teleport objects or individuals could also present new security challenges. For instance, teleportation could be used to bypass traditional security measures, such as border checkpoints, making it easier for criminals or terrorists to transport weapons or other illicit materials. Developing effective countermeasures to these potential threats will be essential to ensure the safe and responsible use of teleportation technology. Economic and social disruption. Teleportation could have far-reaching economic and social implications, potentially disrupting entire industries such as transportation, logistics, and manufacturing. While these changes could lead to increased efficiency and new opportunities, they could also result in job displacement and economic upheaval. It will be essential for society to adapt to these changes and develop policies that ensure a fair distribution of the benefits and minimize the negative impacts. The road ahead: research and development in teleportation. While teleportation may still be a distant dream, researchers around the world are working tirelessly to better understand the underlying principles and push the boundaries of what is possible. In this section, we will highlight some of the current research and development efforts in the field of teleportation. International collaboration. Teleportation research is a truly global endeavor, with scientists from numerous countries collaborating on experiments and sharing their findings. This spirit of international cooperation is essential for advancing our understanding of the quantum realm and unlocking the potential of teleportation technology. Investment in quantum research. Governments and private organizations alike are investing heavily in quantum research, recognizing the potential impact that teleportation and other quantum technologies could have on society. This investment is driving innovation and progress, helping to accelerate the development of teleportation and other quantum-based applications. Breakthroughs in quantum entanglement and superposition. Recent years have seen numerous breakthroughs in our understanding of quantum entanglement and superposition, the fundamental principles that underlie teleportation. These discoveries are paving the way for new experiments and applications, bringing us ever closer to realizing the dream of teleportation. Teleportation is a fascinating and complex subject that captures our imaginations and challenges our understanding of the world around us. Although we are still far from teleporting humans and objects across vast distances, the study of quantum mechanics and ongoing research into quantum teleportation is opening up new possibilities and applications. As we continue to explore the mysteries of the quantum realm, it is essential to consider the ethical, societal, and practical implications of teleportation, ensuring that this powerful technology is harnessed responsibly and for the betterment of all. Once again, don't forget to hit the subscribe button and stay tuned for more informative content. And, for our final interesting fact, in 2017, Chinese scientists successfully teleported a photon from Earth to a satellite orbiting more than 300 miles above the planet, marking a significant milestone in the development of quantum teleportation technology.